world of software engineering and artificial intelligence. Our keynote speaker is Mr. Mayank Sawhney, Senior Engineer Manager at Atlassian. Mr. Sawhney is an engineering leader with more than 15 years of experience driving innovation, building high performance teams, and delivering large-scale technology solutions. Currently at Atlassian 2020 to present, he leads greenfield initiatives in AI, IT service and management, and AI ops. His work includes designing data pipelines for thousands of customers, developing next-generation AI ops features, and contributing to Atlassian's intellectual property with over 15 patents. Before joining Atlassian, Mr. Sawhney spent a decade at FactSet across India and the USA, growing a seed team into an organization of 70 engineers and delivering real-time financial trading platforms with sub-second latency. He holds a postgraduate degree from the University of Maryland, Baltimore County, UMBC, where he also served as a teaching assistant and researcher in data streaming. Today, he continues to lead at the intersection of AI, data systems, and engineering leadership, shaping the future of enterprise technology. His keynote topic today is AI assistance for on-the-call engineer. Ladies and gentlemen, please join me in welcoming Mr. Mayank with a big round of applause.
Hi everyone, I'll just get started. If people can't hear, let me know. I'll use the mic, otherwise it's a small. Is it better? Okay, perfect, awesome. Yeah, so I see a decent amount of crowd. I think we can keep it a little bit casual towards the end. If you have any questions, you can ask me. Quickly, thanks for that nice introduction, but something about myself. I am Senior Engineering Manager in Atlassian. And of the things that we do there, I manage a team of about 45 odd engineers, AI researchers, and we are trying to build products, features that use assistive AI to make on-call easier. Now what that means, I'll explain. But I was thinking about what could be a good sort of a discussion with researchers, professors, students, and also maybe people who have worked in industry through internships or want to join industry, right? So what could be that area where it's a little bit of industry research and also industry application along with some academia. Does anyone know does it mean to be on call? Okay, so I'll explain, right? Has anyone ever heard the concept that I got, maybe you're sitting with your friends or your seniors, right? And you have heard the concept of, I got paged, I am on call, I need to open my laptop, I need to fix the problem, right? So basically the on call is, think about this, right? In the SaaS world, 24/7, we are expecting everything to work. The moment you open your mobile, you are expecting things to work all the time, right? You open your Zomato app, you expect it to work every single time, right? But there are things that are happening behind the scenes that are breaking down, right? There are people whose job is to be online all the time. It usually over a period of rotation, right? I'll be on call for 24 hours, then there will be someone else. But the whole idea is as and when things are breaking, for whatever reason they are breaking, you go online, you open your laptop and fix the problem. Now this is a concept that is not alien to anyone in the software industry, whether it's a big MNC, a small startup, sort of an IT company, a non-IT company. If you have an engineering presence that needs and an engineering software that is running 24/7, you have an on-call. Now, hopefully you can see through this, right? But I want to, again, like, what does that mean in real world, right? You would have seen these Ghibli, whatever you want to call it, right, images. That trend picked up a couple of months back when Sam Altman and OpenAI released their GPT-4 or visualization models, right? So you could just upload an image and it will make a Ghibli image out of it, right? At that time, there was a tweet from Sam, like, can you just stop generating all of the images? Can you just stop pounding our servers, right? Because it became a viral trend. Everyone was uploading their images and their system was breaking down, right? And what he said was, can you just stop this because our team needs sleep, right? So this is quintessential what an on-call is. Because there was a it became viral, everyone was using it, their systems were breaking down, their engineers were getting woken up in the middle of the night, they were trying to fix this problem, right? So this is basically what an on-call is. An on-call generally starts with an alert. Now an alert, what does an alert mean, right? In the case of Ghibli images, right, it could be a capacity that got exhausted. Maybe they had designed their system for 1 million requests a second, but it became 10 million. It can also mean there was a abusive behavior from any spam attack or things like that. It may also mean that you or somebody in your team release a change that created outages, right? By outages, let's say your server went down. There was the entire network bandwidth got consumed up. Your CPU usage spiked up, right? So there could be multiple reasons why something stops working. By something I mean usually a software application, a server, which is just taking a request, giving a response back, right? What happens at that time, through monitoring tools, you get an alert. If you're an engineer, you will get an alert, right? So what is an alert? Example, let's talk about CPU usage. So CPU usage is would be like a trend, right, of a line going like 1%, 2%, 3%, right? Maybe it is changing every sub-second. At some point, it will hit 90%. At that point, it seems like, okay, there's a blip, you need to fix the problem, right? Because if something is at 90%, other things will start throttling. They will basically look for CPU and they will not get it. Now, the alert is not the first blip, but the alert is when something goes up, let's say to a 90% and then stays there for some time, right? Example, something reached 90%, but literally in the next second it came down. That's not an alert because that's like it's a blip, right? But an alert would be your CPU usage spiked to 90%, stayed there for 5 minutes. Now that means it is becoming a problem. And even in your laptops, right, you would see this, like if CPU usage is high, you will not be able to perform the way you are trying to do your normal stuff. So in this case, in the industry, it will create an alert. The alert will go to an on-call person. On-call person is an engineer who has worked on that system. And their job is to log in and figure out, do they have to kill some process? Do they have to increase the capacity? Whatever they need to do to actually handle the problem. Generally, so this is our product that we have been working on. And again, it's a sort of an industry thing, right? Like there are several companies who are offering these paging system support, right? But by and large, it will always look similar to this, right? There would be some sort of a headline, what says over here, right? Prod, EU Central, SQS alarms and things like that, right? So generally it is talking about that the problem is happening in European region in Frankfurt, right? It's not a problem that's happening in, let's say, something that is hosted in Bombay, right? Because in a global setting, you would have server farms spread across the world. So it will give you a headline. There will be some sort of a text that will describe what the problem is about. Then if you see on the right, on the right you can see there is an assignee, which is Sovan in this case, right? So it's Sovan's job to get online. Like Sovan was paged. By paging, he got a phone call, he got an SMS that you come online. So it's Sovan's job. I just took a snapshot yesterday night, and this is like actual real world. It's not theory, right? So it happened yesterday night around 8:30 p.m. when I was making the slide there. Sovan had 11 minutes. It's been 11 minutes since Sovan got paged, and he was supposed to fix this problem, right? So this is a real world thing. It's happening every single day. And when anyone gets paged, they land here, the alert landing page, right? So some context of what is happening, who's responsible, how long it has been the problem started, right? And then they are supposed to fix it, right? Now, why does this matter? As I explained, like the first thing is it costs money. To any big enterprise, why would any big company care about it, right? Think about a situation where, let's say Amazon went down, Amazon.com went down for 5 minutes. The amount of business they will lose will run into several crores, right? Think about your food delivery apps, right? Let's say Zomato, Swiggy, and things like that. If you want to order some food and an app went down for 5 minutes, 10 minutes, right? You would immediately switch on to the next available food delivery app, right? So they would end up losing money. Now it's just one person, but think about this, right? Now we are talking about thousands of users across India, maybe in some cases global also, right? So on an average, every 1 hour a system is down, it will, on an average, it will cost about 15 to 16 crores of lost business opportunities every hour, right? So businesses care. Big enterprise companies care about these things, right? And just by the food example, like, I think it will resonate with you also. The other is the employee time being spent. Now, people who are on call, right, they are supposed to get up in the middle of the night, fix what is the problem, go back to sleep. Next day they are tired, they will not be able to perform. If you do it multiple times a month, generally, like, the morale of the team will go down, right? You will feel tired all through the time because you don't have a predictable lifetime. Like, generally, the separation between your work and like your own time, right? So about 30% of the employees or 30% of the employee time is spent in handling these disruptions. Some of them are during the office hours, some of them, as I said, could be during non-office hours. The other is, while these are the problems that need to be fixed, there is willingness in the industry, right? There are willingness by, let's say, the likes of any big company to pay for solutions that will help reduce these outages. Any big company, if we can build some AI assistive solution that will help them fix the problem, not allow it to happen, or save the energy of the employee, right? For any of those things, there is willingness at all the companies level to pay for these things, right? So let me introduce you to the concept of AI ops. Now what we have established is a business problem, right, for which we can build solutions. So what is AI ops? AI ops is not how you use AI to run operations, right? This entire thing is operations, what I described. The AI ops part is how can you use assistive AI for your on-call operations, right? How can you build a co-pilot that will help these engineers who are getting paged? How can they triage the alert, basically figure out what is going on? How can they find the right information? Again, like doing that all in real time. Figure out that the problem is only in, as we saw, right, in EU Frankfurt, not in India, right? So go log into that place. Even in that place, where exactly is the problem, right? So do that fault localization, your blast radius estimation, right? All of these things are super important because it will help it will help the engineer to quickly resolve the problem, both helping their time and saving business a lot of lost opportunity. In the end, the goal is to fix the problem. So this is generally how the typical alert is managed. I would not go in a lot of detail here. But basically, it involves few steps, right? When you get paged, first you want to triage. You want to figure out where the problem is, right? Which system it is in. So you would first act the alert. You would look for a runbook. Runbook is if you are paged by something, if something told you like the CPU is 90%, then do what? A runbook would have a list of steps that will tell you go and add another CPU, right? In a cloud setup, you could do that. Or go and kill the job that is hogging all the CPU, so that you kill one so that 99 other jobs can survive, right? So those are the steps, right? You would also look at the context. So basically what you're trying to do is you're trying to triage the problem, right? Then what the next step is usually remediation, right? Now if there is a major problem in the setup, for whatever reason it happened, right? The goal at that moment is not to go to the root cause of it and fix the problem like from the get-go, right? The goal at that point is to make it live again. So if, let's say there was a bad setup that was released for any e-commerce app, right? You would immediately cut that out and go back to the previous setup. Or you would divert the traffic from, let's say if there was a problem in one data center, let's say in Bombay, you would redirect the entire traffic to Hyderabad. You are not going to go and fix the problems in the data center in Bombay, right? So at that moment, the goal is to remediate very quickly, in minute, 2 minutes, couple of minutes, whatever that number be. And the last step is to then actually go and fix the problem. Now that can take even months sometimes, right? But identify the problem, fix it immediately with whatever is possible, and then actually go and fix it for good so that it never happens again. So this is a very typical alert management problem, right? Now I want to take this industry problem and explain how can we take the normal research that we are doing maybe in academia uh, through common concepts and use it to build solutions that can help with this assistive on-call, right? So first let's talk about alert prioritization. Now what is happening, let's go back to our CPU use case, right? It is, we, we got alerted at 90% of the CPU usage. The next alert will come at 90.01. The alert after that will come at 90.02, 90.03, right? So what's happening is in a real time, you are getting tons and tons of alerts, basically talking about the same stuff. It is talking about the same problem, right? There is no new information there. So the issues that come with this is what you're trying to do is you're trying to compare two different things, right? So alert 1 with the alert 2. In both of the cases, you are doing in some shape or form string matching, right? You are comparing, are they both talking about same thing? There is a lot of text. One is talking about 90%, the other is talking about 90.01%. So by and large, you are talking about same stuff. You are not getting any net new information, right? So it's basically the same concept. If you worked in the AI space, you would resonate with words like concept drift, real-time inference, and things like that, right? Now, real-time inference, I'm talking about, we are doing millions of these inferences if two things are correlated or not per second. You can easily take two text files, give them to ChatGPT and say, are they similar or not? That will take at least 3 to 4 seconds. We have to process thousands per second, if not millions per second. So your normal LLMs will not scale here. So these problems, I don't know if it's fully visible or not, but these problems need to be solved with unsupervised learning, where there are multiple reasons for it, but I'll explain them maybe later. So unsupervised or semi-supervised learning, but it can't be your normal LLMs that are being used for comparing two things, right? First reason is it's going to be super expensive. Second is the latency is going to be too much, right? So I was explaining that example of CPU usage, right? Again, I don't think it's legible, but still what's happening on this highlighted box is it's basically the same alerts or similar alerts. Everything is individual, everything is unique, but they are talking about same thing. So what we have done is we have put them together, right? So instead of getting paged by page, I mean you get a message every second, right? Instead of that, you can just get one message for thousands and thousands of alerts, right? So it doesn't bother you. Now the way these things are solved, again, like from the world of research, you can look up log segmentation problems, right? Where how are you segmenting the logs and things like that. Those can be applied here, right? Concept drift problems in research are about determining when a concept is changing. When I'm going from CPU usage to DB usage, right? But what we are using here is actually counter to that. What we are trying to figure out is, tell me when the concept is not changing. Tell me when it's only CPU is what we are talking about, so that I can put all of them together and not bother the person. So the research problem, but the application is exactly opposite of it. Algorithms basically remain the same. Let's talk about another use case, signal and noise. Again, like on the right side, you can see in the highlighted box, right? So it will, each alert when it is coming, right, it will also, it will have generally a text that is generated by a system, right? So that would be your CPU metrics, it could be your generally log dump and things like that, right? So it is becoming difficult sometimes for a human to understand what is being talked about. And more importantly, whether it is signal or noise. So what is a signal, what is a noise? Let's think about this, right? Every Diwali, there is some amount of search, right? Whether there is on an e-commerce website where people are ordering a lot of stuff, right? So there is a lot of preparation happening for whatever the Diwali sales that go on in different e-commerce website, right? So maybe there are some things that we are expecting to alert at that time, right? So those are your noises. They may not be signal. Then there may be some issues that happen only on a Friday evening. Example, on a Friday evening, people are going out, they are ordering a lot of food. So between Friday, let's say 4 p.m. to 9 p.m., there will be a lot of rush. So there will be metrics that are firing alerts, let's say again, your network usage is going up and things like that, but that is expected, right? It is not a new signal, you are expecting that, right? So you are getting notified only because you want to know what is happening in your software system rather than you need to act upon it. So generally speaking, noise, right? Signal is when you are not expecting something to happen, but it is happening, right? I don't expect to get paged for such a huge number of orders on a Monday morning. If let's say I'm a food delivery app, Monday morning nobody is ordering, right? But if I'm getting too many alerts at that time, it means someone is trying to abuse the system or there is some intrinsic problem happening in the system, right? There could be like fake orders and things like that. So there could be abuse, there could be genuine mistakes, but whatever it is, if it is breaking a trend, I want to get notified as an engineer because that can create monetary problems for my company. Now, what is a research problem here, right? Again, if if you worked in the world of AI, anomaly detection is a very commonly used sort of, or aware thing, right? Everyone is aware of it. So anomalies are what we are looking for here. First, we are trying to establish a trend, looking at the past alerts for the past 1 year, 2 year, whatever, right? And we are defining the trend using both the words, the temporal analysis, or what words are in the alert, what is the temporal analysis, and trying to figure out, okay, I expect order numbers to go very high on a Friday between 5 p.m. to 9 p.m. Right? So that becomes my temporal analysis and also like some textual also, right? So this becomes a trend that I am learning. But what I'm trying to alert on, I'm not trying to alert on a trend. I'm trying to alert when the trend is breaking. Example, as I said, I'm getting alerted on a Monday morning, right? So anomaly detection is not for removing the anomalies. Anomaly detection we are using to actually alert and send a high priority signal to the engineer to go fix the problem, right? So again, a research concept for a practical usage in the industry, maybe but used in a counterintuitive way. Okay, so next thing when you get paged is you would like to figure out, has it happened before, right? Not everything happens for the first time, right? Things are like maybe on a Friday, maybe on a Monday, like certain things are happening, right? So you are seeing it for the first time, but your buddy from your team has seen that in the past, right? So a knowledge retrieval is what it is doing is it is trying to figure out the current context, what is happening as of now, and trying to go and match it with the context from the past. Has it happened in the past, right? And alerts and all of these things are seasonal because it's also human behavior, right? You got paged about something, there was some problem, you didn't fix it. What you did was you just smacked it, moved on, like the problem will solve by itself, right? So there may be some prior context also or prior occurrence also. So again, real time current context matching with the historical context. And this is a very similar, again, like I don't think it's legible, at least it's not to me. But what it is happening is, right, like at the top, there is context around what is happening right now. We are using normal your RAG pipelines. Again, RAG is a very commonly understood concept these days, right? To go and match the current context. It is not this just simple textual search, right? It is beyond that. Like example, there is some recency factor to it, right? So just doing indexing everything, putting RAG in front of it, and trying to figure out the right right places where this information about what the current problem is, right? So it is called knowledge retrieval. This is a well understood concept, and I would say not very high on research factor. Let's talk about the third, explainable root cause. So when a problem happens, right, like how does it look? Example, my service is called service X, right? Now that is going down, it had an outage for whatever reason, right? But I may depend on person X, a person X may depend on person Y. By person I mean even referring to services, and service Y may refer to service Z, right? So there is a lot of dependency also involved. So if they are having a problem, I will have the problem without me doing anything about it, right? I didn't do anything, right? So you can think about this, that in any big multinational company, the software services are laid out in a graphical fashion, right? I depend on some microservices, right? So microservices architecture, but I mean like at a big company scale, right? So how does that even look like? This is again real. This is as good as yesterday in our own company, right? Maybe your problem is somewhere in the middle, right? And these are all the connection, all the requests, how they are going. As I said, it is all real. It's not made up, right? Now, if you try to figure out the problem, I got paged, I need to know what happened, right? You have to go and look at all of these places. Are they breaking? what were the changes happened in those places that are creating trouble for me, right? So there is all these interdependencies. But in a real world, it doesn't even look like this. It actually looks like this. Now you try to figure out when you got paged, why is something happening? It is indeed finding needle in a haystack. Again, it's not made up, it's real, right? So finding the information from this, right? So I've highlighted the problem I got paged is here, but this is how my world looks like. Now you go and figure out under stress, you are woken up in the middle of the night, you are already tired, and you are under stress because it needs to be fixed in a couple of minutes, maximum an hour, right? In that setting, you are trying to find where the issue is, right? Now, so it basically becomes very difficult for a human. A human who has worked on this system for 5 years will perform much, much better than a newbie, right? But again, like we can't guarantee all that, right? Like the people have a lot of, so there are onboarding flows and things like that, right? But again, depending upon the maturity of the on-call engineer, the response time will vary. But what we can do is we can teach this muscle memory of experienced on-call engineer to go and use AI to figure out all of these changes, right? You can completely deploy one model that looks at all that is happening in this world and try to give you maybe 3 or 4 top reasons of why a problem is happening, right? And that is called root cause, identifying the root cause. There's another problem with this, right? Like how do you represent your data? Example, your logs are free flowing stream of text. There is no structure to it. Your maybe your application logs or like there could be some structure in how many requests are coming in, things like that, right? Maybe more numerical. Now on the other side, you have your CPU, as I said, CPU metrics, a different type of metrics, right? Those are a real-time stream of numbers with different sort of frequencies and like things like that, right? So they are represented differently. Logs are just free-flowing text, that is represented differently. So how do you even model the data where representations are different becomes also a challenging problem. So this is, for finding these things, we use different graph models, causal inference, but again, the whole idea is using how can you make a graph model work on heterogeneous, huge data sets that are updating with each second. Last thing I want to talk about is the human AI trust. So when I'm building the solution, who's my end user? My end user is a highly educated software engineer, right? They would not trust any AI solution. The moment you get an answer, they'll be like just moving on, like scroll through it, let me go and figure it out, do it by myself, right? That is generally the approach. You don't trust AI, right? So how do you build that UI and user experience design that help build the trust with the person? Because see, at the end of the day, if anyone tells you that AI-based solution is going to be 100% accurate, people start rolling their eyes, right? You don't believe in it. Because it will not be 100% accurate. You will make some mistakes, right? The system will make some mistakes. So how do you, in spite of doing that, how do you build trust with the user over a period of time so that even if you are wrong, but you are still assisting them in their problems, right? So that is another problem. Let me go back to the signal and noise or the anomaly detection problem I had explained before, right? So on the right side, we explain the full text, right? So it talks about, in a human, well understood, like easy to comprehend format, it will talk about why did I say that this was a signal, why did I say this was a noise, right? I will go and explain that I am expecting this problem to happen in a certain time frame, and this is not happening, this alert is not fitting in that time frame. So regardless of whether I'm right or not, but I explain by, I mean a AI model that we have built will explain the thought of the model itself. Why I am suggesting what I am suggesting, right? So in a way, it is becoming your co-pilot, right? Or your teammate who's working with you rather than telling you what to do. So you can take this information and build on top of it. You do it multiple times, then the trust between the model and the human starts to build, right? Again, UI, UX designs, responsible AI, and these things are also industry problems. I'm just giving you one way how can you build trust, because at the end of the day, using AI in your normal day-to-day job is a new paradigm. We don't know how to search using ChatGPT, right? We are also learning, right? Some people have become good at it, right? But basically when there is paradigm shift in behavioral aspects of how do you use a software, you have to build it over a period of time. Immediately, people will not even trust it. They will not know how to use it. So UI UX plays a significantly important part in any sort of industry or when we are trying to plug AI in your features. Again, like, so this is one of the incidents. Again, it basically talks about what are the problems, why I am suggesting, and things like that, right? So building that same trust, right? Similarly, over here also, what we do, another way we can highlight this is how confident are we in our solution? Are we medium confident, high confident, low confidence, right? So that user also knows, because at the end, I'm giving one suggestion, but internally, I have maybe some threshold, some benchmarks, right? If the confidence is above 0.9, say high confidence, right? So that the user may treat it as such. If it is a lower confidence, give that information also, right? So these small aspects, like there is a lozenge here marked in yellow color saying medium confidence. Without even reading through it, you quickly realize it, okay, the confidence value in the AI is on a okay side, right? So I may take it with a grain of salt, right? So all of these small things are super important when you're trying to bring about a behavioral change and also build the trust along the way with the user. By user, again, as I said, is a software engineer in this case, but these concepts sort of hold true for non-software engineering users as well. Okay, so this is possibly the last slide I want to talk about around the engineering challenges, right? When you are building sort of a solution in an enterprise world, enterprise like as an MNC, right? There are a lot of challenges there. Example, I can't even look at the user data. So whatever queries we are putting in Google or ChatGPT, a human cannot look at it. A human working in ChatGPT or OpenAI or Google cannot look at what you are searching, because that is the breach of privacy and trust, right? So in an enterprise MN where we are building these things, I can't look at what my users are doing. So how do I know that it is going to be a high quality response? So you have to look at not the exact queries, but you have to look at the metrics that will talk about those queries, right? So eyes on data access in an enterprise setting is not possible. In academia, it is generally possible. But what is a good research problem is, without looking at the data, how can you tell whether the model is doing good or bad, right? Another thing is tenanted models. So tenanted models, example, this whatever I'm showing here, it's being released to at least 10,000 customers. Each customer being, let's say, I'm just using an example, Pepsi, right? Pepsi may or may not be our customer, but Pepsi or Coca-Cola, right? These are two different customers. Each customer will have also thousands of users under them. So I'm talking 10,000 customers, thousands of users under each customer. So you can imagine the scale. You can just multiply and imagine the scale of it, right? But another problem is ChatGPT or all these big LLMs, they are one big model that works for all the customers. Whatever you are searching goes back into that big model, that learning goes back to the big model, and then that information is spread over to whoever is searching next. But in an enterprise setting, that's not okay. I cannot learn on, let's say, Tesla, because Tesla is using our software, example, and then go and give that same information back to Tata, right? Because that is not how it will work, right? So these tenanted models, example, one model per customer is a requirement. You can't have like one big model. You can fine tune or do whatever, right? But basically the fundamental goal is information leak from one enterprise customer to the other customer should not be there. So you can't just just share the information. You can fine tune it, keep it separate. As many customers you need to have as many models. So privacy is one stuff. The other is around tenanted models. Trust, we have spoken during this meeting, right? Like about, or during this discussion, you cannot get eyes on data access, right? But the other is also you need to be highly accurate. If you are giving out garbage solutions, people will not trust over a period of time. So without giving out garbage solutions, without looking at the data, how you can make it a good suggestion, right? Again, that takes time and it's difficult. Last thing I want to talk about is COGS. COGS is sort of cost of goods sold, right? TLDR, what is the cost of running an operation? Right? Now, if any operations that are running on these public LLMs, whether they are OpenAI or whatever provider you want to pick, they are very expensive to run on an enterprise scale. Example, I can be asking maybe 10 queries per day to a system, right? And I'll do it throughout the month. But at the end of the day, I'm paying just maybe 300 rupees, 400 rupees for that system. So just the cost of running those queries on these public LLMs can sometimes far exceed the cost of, or rather the revenue that I'm getting from those users, right? So keeping the cost very low is also a significant part of our how do we optimize, right? So it may basically mean in like we host our own models. It may also mean that not everything is done through LLM, because that, unlike common perception, which is now put everything on the LLM, the cost and the latency both become a very important factor that we have to manage. If we are trying to make some money out of it, we have to keep the cost low, right? So we also go back to our traditional ML approaches rather than just send everything to an LLM. So this is about cost, and that's where I want to stop today. Again, my goal today was to explain an industry problem and maybe tie it back to the research that is happening in the academia on how we can take those research and put it into real world solutions rather than something that doesn't see the light of the day. Again, like I'm representing, I work at Atlassian. I may not be representing them here, but Atlassian is a company that is sort of a global MNC. If you have heard words like or tools like Jira, Confluence, Trello, Jira Service Management, right? These are all enterprise tools for project management, for documentation, and for other like basically collaboration tools. Like Atlassian is known for those things. If you are interested in applying for Atlassian, you can go hit the careers link, apply there. You can also reach out to me on LinkedIn. I can help you out with whatever possible. And last thing, I've worked with folks from NIT Delhi. That's the reason why I'm here. That's why I got to know this existed. I think it's a great institution. I've worked with someone for several years. So definitely I trust the caliber in NIT Delhi, and I hope today I was able to give you maybe some aspect of, again, industry research, AI. Thanks everyone.
Thank you so much, sir, for that insightful session highlighting how AI can empower engineers in real-time operational excellence, and also the deep dive that you gave us with AI Ops. Now, I would request Professor Dr. M. Devanathan, TPC Chair, to felicitate Dr. Mayank Sahni. With this, we now proceed to the parallel technical sessions, followed by high tea. Enjoy the sessions and take a refreshing break afterwards.